My name is Cmpe and this is a demo of my project called Mini Key Value Nosql Database. In this, I am creating a replication model where I am keeping a Nosql database on all of these three EC2 instances, and my work is to maintain a consistency between these instances. Now, I'm using a peer-to-peer model in this project where every request can be processed by any node in the system. Now, my main focus here will be availability and partition tolerance, which means that whenever there is a partition in the system, my system will be available for users and it will respond to users' queries with data which will not be completely consistent, but it will still be useful. For this, I have created an elastic load balancer in which I have three different instances. These instances communicate with each other on port 8080 and they are open on port 80 for external communication. EC2 is also open on port 80. I'm posting this data. Yeah. So there is a successful entry at 196. And when I get it, it will be available on all the nodes. Now here you can see the version is 1 because this is the first insert we are doing for this record. There is a timestamp associated with this record. This timestamp indicates the time at which this data was entered at the node where the request was processed. That is where the request came from port 80 and the node processed it, and then this node associated this timestamp with the record and passed this record to remaining two nodes. Now the remaining two nodes, if they do not have the record, they place it in the database. But if they do have, they must be having a timestamp like this associated with that record. Now they will compare these two timestamps and verify which one is the latest and place that in the record. Similarly, we'll do put. I have as you can see, it is updated at 250. Now when I get it, it will be version 2 on all the nodes present. Now when I delete it, the menu, delete, successful delete at 196, and when I get it, there is no record. So this is how my system performs when the network communication between the nodes is proper. Now suppose if I have a partition in my network. Now for a partition, for one node, I'll be removing the inbound and outbound 8080 communication for the demo. So these are the two private IPs on which my node was communicating. So when now my system will be in partition, my focus will be that every record will process the request. Here, if a record, every node will process the request. Now, if a node can communicate with other node on the network, it will pass it to that node. But if it cannot, then it will maintain a queue for both the nodes it has. Suppose there is node A, B and C. Now if node A cannot communicate with node B, it will maintain a queue for separately for node B where every request which it has to send to node B will be placed in order, in proper order in which it came. Now whenever the network recovers and node A and B can communicate with each other, this request will be processed in the order in which they occur. Now how does node B identify whether this record is needed, is something it has to update or it has to ignore? This is where the timestamp associated with each node will be useful. Now this timestamp is basically a universal timestamp coordinated format. Universal timestamp coordinated format. So every node will store the timestamp in this particular one format only and no other format. Now whenever a request comes, this node will check the timestamp of the record and check the timestamp of its own record. Now it will compare both the timestamps, and if it has the latest one, it will ignore the request. But if the request has the updated data, it will update its record. Now how this works is because I am at the first place attaching the timestamp with every record when the record was inserted. That is, it is not the timestamp at which the node receives the request, it is a timestamp at which the sending node had processed the request. Therefore, even if there is a delay or a network partition, the timestamp will remain the same as it is, and this timestamp when compared will help us identify whether our data is old or new. Plus, second thing I'm doing is I'm queuing the request. I'm sending the request in the same order as if there was no partition. Therefore, whenever the partition recovers, all the initial requests whose timestamp is before or is outdated, they will not be processed, but all the new requests will be processed. So as the requests are processed in order, there is a guarantee that there will be a consistency at the end of recovery, which I'll show you here. These are my 3 EC2 instances on which my NoSQL database is present, and these are the health checks which are currently going on in the by load balancer to check if the EC2 instance is alive or not. So now, as you can see, there is a successful entry at port 250. Now when I get it, there is no record at 196 since it is partitioned. This record has been placed at 109 with version 1. This record is present at 250 and is not present at 196. Now suppose I insert at 196 the same value. Okay. It is inserted at 196. You see, this record is not at 250. It is at 196. It is present at 196 with version 1. And it is not on 109 as well. This is because I have closed the inbound and outbound access of 109. Oh, sorry, I mean 196 port, and that's why there are no communication of this node with any node in the network. Now when I again recover the network, for now I'll keep it for anywhere. I otherwise add private IPs of my nodes. As you can see, this record has been updated at 250. It is there on 196 as well, and it's there on 109. Now similarly, as ident for record menu, it is there on 250, on 196, and on 109 as well. So as you can see, as we insert in a non-partition network, but I'll show you put as well. So for now, suppose we take another instance and we remove that instance from the network. Say get. So I'll put on my menu field, and I'll remove these values, and I'll make this as 5151. Okay, and we update it. Now it has been updated on 196. Now when I come here, it's version 2 on 250, which is the updated field. It is version 2 on 196. It's still version 1 on 109 because it is not in, it is partitioned. It is not in the network at present, and there are no communications going on between the nodes. So now in between this, suppose there is one update which has already happened on 196, but I update this record again on 109, which is currently not in the network. I remove this field as well, for example, and update it. So it is updated on 109. So now when I get it again, I see version 2 on 250. I see version 2 on 196. I see version 2 on 109 as well, but this version 2 is different compared to other. So now accordingly, since on 109 there is a latest update, it should be replicated everywhere. There's a version 2 and this is one. Okay, this is 109. See, the version 3 is there on 250, but this time the value is what is there on 109. So the latest field has been updated according using the timestamp. This we are saying version 3 because there was more version involved before this, and there was no version involved in 109. So this is how my system performs when